Hello students, how are you? Hope you are doing well. Now the question is, a cube of side 0.1 meter is placed as shown in the figure in a region where electric field E equals to 500 x I cap exists. Here x is in meters and E in Newton per coulomb. Calculate part A, the flux passing through the cube, and part B, the charge within the cube. So the problem is based on the concept of the flux, which is related to the electric field, and the area vector as E dot A, and phi equals to Q upon epsilon naught. Now this particular formula is used to solve the A part of the problem, and this formula is used to solve the B part of the problem. Now for the A part of the problem, we have to find out the total flux passing through the cube. Now if you see that the electric field is given as 500 x I cap. Now this x denotes that the electric field is position dependent. It is a variable kind of electric field. As x varies in the positive direction, the electric field increases because it is 500 times x. So it is a variable kind of the electric field. First of all, for this particular cube, you can easily see that these two surfaces, for example, we name this particular cube as A, B, C, D, A dash, C dash, D dash, and B dash. Then the particular face, which is A dash, C dash, the electric field line passes through this face. Similarly, for the face D dash, B dash, the electric field line passes. For the particular face D, C dash, D dash, the electric field lines are perpendicular to the area vector, so we need not to calculate the flux corresponding to this. Similarly, for the top surface, that is A dash, B dash, C dash, D dash, the area vector is perpendicular to the electric field, so we need not to calculate the flux corresponding to this surface. Similarly, for this particular surface, the lower bottom surface, we need not to calculate. Similarly, A dash, B dash, A, B, this surface, we need not to calculate the flux because the direction of the area vector is perpendicular to the direction of the electric field. So the only two faces of our concern are the faces A dash, C dash, AC, and B dash, B, D dash. So these surfaces are of our concern. So for the left side surface, this is A dash, C, we call the flux is phi L. Now phi L is basically equal to the dot product of E and A. Now the direction of E is towards right, whereas the area vector is towards the left. So we can say that there is an angle of 180 degree between them. So when cos 180, the dot product, it is EA cos theta, where theta is the angle between E and A. So we can say that this is minus E into A, because cos 180 is minus 1. So the value of E from this particular formula, 500 times x. Now this x corresponds to this distance 0.1. So we can say that this is 500 minus 500 times 0.1. And the area vector, area we have to calculate, area is, because the cube is having a dimension of 0.1 meter, so 0.1 meter whole square. Now after solving this comes out to be negative 500 times 0.1, 0.1 times 0.1 times 0.1. So this value comes out to be minus 0.5 Newton meter square per coulomb. This is the flux corresponding to the left surface, and the direction is towards the left. In a similar manner, we calculate the flux corresponding to the surface B dash, D dash. So this particular surface, we can say that it is equal to plus, because E is in the rightward direction, whereas the area vector, which is normal to the area, is also in the rightward direction. So the angle is 0 degrees, and we can say that cos 0 is 1, so that this is a positive value. So this is E into A. Now to calculate E, 500 times x. For this, x is 0.1 plus 0.1, which is 0.2. So this is 0.2, and area is same as 0.1 whole square. After solving this value comes out to be 1 Newton meter square per coulomb square. So this is the area corresponding to the right surface, phi sub r, which is this particular surface. So the overall flux corresponds to phi total corresponds to phi L plus phi R. So after adding these two, minus 0.1 plus 1. So this value comes out to be 0.5 Newton meter square per coulomb. This is phi total. So this is the total flux and the answer of the first part of the problem. So this is A part solution. For the B part, we have to calculate the charge enclosed. So from this particular formula, we can see that Q equals to phi epsilon naught. Now phi total is 0.1 and epsilon naught we know that 8.85 into 10 to the power minus 12. So after multiplying it, we get this value as this is Q is phi total is 0.5. So 0.5 multiplied by 8.85. So we get this value as this is 8.85 divided by 2, which is 4.425. 4.425 into 10 to the power minus 12 coulombs. So this is the answer of the second part of the problem. So hope you understand the solution. Thank you.